Okay, this is my task 1. So I have a whiteboard. I just wrote task 1. So the task is to draw a chiral compound and its enantiomer. So I'm going to start with drawing the chiral compound. Okay, so this is an example of a chiral compound. It's a chiral compound because it's non-superimposable, which means when you draw the enantiomer, it would not be able to just like go on top and like have the same molecular geometry or overlap each other. So I'll draw the enantiomer now. Okay, so this is the enantiomer, and as we see, like if you were to like try and take this and put it on top, it wouldn't like overlap, or it wouldn't like be the same. And that's because what makes them enantiomers, the properties that make them enantiomers, is the fact that even though they have the entire same makeup, they have a different molecular geometry. And yeah, I think that's the entirety of the question. Yeah, the specific relationship between enantiomers is that they're the same but different molecular geometry. Okay, task 2 is draw a pair of compounds that are diastereomers. So I'm just going to use the same one that I used for task 1, but draw the diastereomer. So an example of a diastereomer for that one would be like this. Because we see that the hydrogen stayed the same, but then the chlorine bond changed. So a diastereomer is when half of it, or part of it changes, but part of it stays the same. So it's not, the enantiomer is when it's like complete mirror opposite image. And this is just half for the diastereomers. They can have different physical properties, because some things change but some things don't. So yeah. Okay, and then for task 3, I just wrote task 3 already. Draw an example of a meso compound. So this is a meso compound. I like to do this one. Oh gosh, that's a funny drawing. Okay, so this is my meso compound, and what makes this a meso compound is the fact that it's achiral, and that if you split it down the middle symmetrically, it is symmetrical. So if it can overlap, and it would be symmetrical. But what makes, so it's like a meso compound is achiral, but not all achirals are meso compounds. That's because what makes a meso compound significant from achirals is the fact that it has chiral centers. So this one has, we see 3. Okay, this is how I did task 4. I'm not entirely sure this is right, but it made sense to me like this. So this is how I'm gonna walk it through. So I started by drawing the figure, and then you kind of write down the chiral center is attached to 4 things, and then I write down each thing that it's attached to. I'm gonna have to like erase this a few times because it's not very big. So we start off with it's attached to, on the bottom, just the H, and then when you go to the right, it's attached to an O, which is attached to 2 carbons and a hydrogen, obviously. Carbon, carbon, and then I write the heart. That's not what I just wrote. Hold on. carbon, carbon, hydrogen. I write the hydrogen for the last one attached to the carbon, like that. I just draw it out to make it make more sense. So hydrogen, oxygen attached to carbon, 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 hydrogen. And then on top you have a carbon attached to another carbon attached to two hydrogen. And then the last one over here, you have a carbon double bonded to an O. And the carbon. So then a carbon double bonded to an O. So you do it like two separate things, and then it's attached to another carbon. Okay, and then, so this is the list of, oh my gosh, my chair. Sorry. This is the list of all of the chiral centers, and then you number them based on, I think it's based on electronegativity. I know it's like based on whichever one's like, has more, is like bigger, or has more of a weight. So this would be number 1 because you start by looking at the first molecule. So oxygen, this one would be number 1 because O compared to C and H. And then these two are both C's, but this one has 2 O's and a carbon, and this one has 2 hydrogens and a carbon. So this would make this one higher than this one, and then hydrogen would be number 4. So it would be 1, 2, 3, and 4. This is me numbering them. I'm going to really quickly just number them on my picture and then erase what I just wrote so that I can have room to draw the next part. So hydrogen is number 4. This is number 1. Except I didn't write that. This is number 1, 2, and 3. Okay. So now, I didn't even use that. So now this is my picture and those are the numbers. Now you have to get 4 to go to the back, which the back is represented by the dash lines as far as I understand. So, what makes sense to me, because if the dash represents the back, or like going out to the back, because bold means it's coming like out towards you. So if dash means it's in the back, then I'm gonna rotate 4 and 1 and switch them so that 4 would be in the back. Even though like it's a little confusing because normally in the pictures that we've done in class, the back is like back here, but I'm kind of just going off of the dash being supposed to represent the back. Otherwise, like I would switch 4 and 3, but I'm going based off the dash because that's what my gut's telling me. So I'm gonna flip-flop these two. 1 would be here, 4 would be here. This would make it go 1, 2, 3, 4, which that's clockwise, right? Yeah, that would be clockwise, which would be going to the right. So I'm really bad with clocks. So that would be clockwise, meaning, sorry, I'm pulling the question back up in front of me because my computer was just off. And show how to determine the RS configuration. Okay, yeah, so that's how you would determine it. And I would flip these two, making it go 1, 2, 3, 4, which I can draw. And then, let me just draw it to make it make more sense. So then, these two would flip-flop, which would make this be O, and then 1, 2, we'll pretend that makes sense. And then, wait, this isn't supposed to be like that. then this would be H, and this would be this group. That looks funny. Okay, my drawing is not amazing, but I think this makes sense. So then this would be the first group, this would be the second, this would be the third, and this would be the fourth, like that. So then it would rotate clockwise, which means clockwise is right. It would be an R configuration.